Oh my gosh. Good morning, JAWS Days. I am so happy and excited to be able to speak with you again today. My heart is very full today. Every time I come to Japan, I get such a warm welcome. It's always just so wonderful to see all of you and to say hello and to make new friends and to reconnect with existing ones. And it's for sure one of the highlights of my year, each time that I'm invited and I receive your very kind invitations to come here to JAWS Days. So thank you so much for being here. For those of you who haven't met me, just a little bit of background. So I'm Jeff Barr, and my official title is Vice President and Chief Evangelist for AWS. I've been at Amazon for almost 24 years. I started working at the very, very beginning of our work to build and make web services available to developers. I was able to work with Andy Jassy directly when he wrote his famous narrative documents defining AWS. And for most of my time at Amazon, I have had this incredible responsibility to understand our services and to share those with developers all over the world. For 20 years, I wrote the AWS news blog, where over the course of that time, I wrote about 3,200 posts announcing new AWS services and new AWS regions. After 20 years of writing, I thought that was kind of enough, and I spent all of last year traveling the world to speak at various AWS community days. I managed to visit 14 different countries in 2025 to speak to developers all over the world. And as I do that, I think all of that speaking and the opportunity to be able to connect with developers and to sit down and really listen to them has helped me to get a little bit of better sense of some of the opportunities and the challenges that developers are facing today. And a lot of those actually revolve around the fact that the very concept and practice of software development, of building applications, it feels like it's changing more quickly than ever before. So we're going to review some of my thoughts and ideas. I'm going to talk about some internal projects at Amazon where we've learned a lot about ways to use generative AI or Gen AI productively and safely. And I also want to give you some of my thoughts and advice on how you can best prepare to really succeed and to prosper in this new world of generative AI. I was going through, so interesting fact, we are getting ready to celebrate, coming up later this month, we're going to celebrate the 20-year anniversary of AWS. If you remember your history, we launched Amazon S3 on March 14th of 2006. And we think of that as really the official start of AWS. So in preparation for that anniversary, a lot of my colleagues came to me and said, Jeff, you've been around here for a long time. You must have some really good pictures and memories of history. So I spent several hours going through all of my photos dating back to about 2002, 2003. And I also was lucky enough to find just a lot of great pictures of my time here at JAWS Days. My favorite for sure, the one in the top left, that was the very, very first JAWS meetup in 2010. So just about 16 years ago. And was anybody here at that very first meetup besides me? I'm the only one? Ah, yes, hello. Okay, we've got one, amazing, that's awesome. That was our first meetup. And even though it was small, what I find fascinating about these meetups is whoever's there that's the right audience for the meetup. The size, the number of people, that doesn't matter. What matters is the right people show up. They are interested to learn and to connect and to say, this is just a beginning. We can work together to build something really big and really powerful. And when I think about the growth of JAWS UG over the years, that's exactly what all of you have done, with a lot of intensity and passion and hard work. So just a kind of a quick look back at a few JAWS days over the years. I do like to use AI as part of my presentations, but I also do like to acknowledge that. So you will find in my presentation some AI-generated images, but I also make sure that I include the prompt that I used to create those images. So I want to talk really, I've got 4 sections to my talk today. I want to start with a bit of a survey to understand where you are with generative AI. I want to spend a lot of time talking about something that we did last year called Project Mantle. We learned a lot of lessons about how our developers are able to be productive with Gen AI as part of that project. I want to talk about some of the ways that the world of development is changing. And I want to give you some of my advice and recommendations on building the skills that are going to help you to move forward into this exciting next generation. Okay, so I want to ask you a couple of questions. And if you would like, please raise your hand to give me a sense of where you are with generative AI. If you don't want to raise your hand, that's totally fine too. I understand that. So let's use your famous bullet train as an analogy. We all know that AI and generative AI, it's moving very fast. For me, I find that almost every day there's something new. Maybe it's a minor release of a brand new model, maybe a new development tool, maybe it's a whole new way of thinking about development. It seems like we're speeding into the future, at least to me, maybe more quickly than ever before. And what I'm hearing for developers, this is a really time that's both challenging and exciting together. So let's kind of think of our kind of personal status and our connection to AI as if we were looking at that bullet train. Okay, how many of you think that as all this technology is moving forward so fast, that you are fully understanding the new tools, the new models, the methodology, that you know basically all there is to know about that field? Good, okay, that's really good because I don't think I know everything either. Now, how many of you kind of think that this is so fast that the train is just like speeding past me? That's me right now. Anybody else? The train speeding past you? Feel free to raise your hand if you'd like. Okay. Ah, yes, okay. This is how I feel every day. There is so much happening. I spend some time studying, trying things out, watching videos, talking to people, but I'm still thinking, so much is happening. I really don't know if I'm actually keeping up with this train. How do you feel like a little bit lost? Like you're not quite sure what this is all about? Maybe a little uncertain if this is something for you? Okay. Or how many of you say, I really don't even like this whole new concept at all. It's just not for me. Totally reasonable. If you think AI isn't the future and you don't want to be part of it, that is absolutely reasonable to think that way as well. But those are, I think, some of the different options and choices that we face right now. I want to spend some time talking about 2 related pieces of technology. I'm sure most of you know about Amazon Bedrock, but underneath Bedrock, last year, we started a project to rebuild everything inside of Bedrock to make it even better at giving you access to so many different AI models. Let's quickly review all the different aspects of Bedrock. You probably mostly think of it as the infrastructure to host and run your models and to perform inferences. But there's a lot more. There's features for customization. There are safety features such as guardrails and policy checks. And there's a very broad set of features to let you build applications that make use of agentic AI. All of this rests on top of built-in security to protect your information, protect your prompts, and so forth. We have been evolving Bedrock very, very quickly. Last fall, in December, at reInvent, we added 18 brand new models to Bedrock in a single day. So you can imagine that the systems, the infrastructure underneath this have to be able to deal with all these new models, all these requests as they're coming in. I looked at the overall Bedrock product catalog. It seems like as of last week, we had 277 unique models available in Bedrock. So all of this delivers a lot of choice for you as customers, and that's what we want. But it also means that we have to have very robust, scalable infrastructure to actually run all those models. These are some of the challenges that we have faced. We need to support this collection of models that seems to be growing, model after model after model, almost every day. Now, it's also the case that the inference jobs that you supply to Bedrock, there's a very wide range of latencies or time durations that these inference jobs take. Some of them might run in 10 to 100 milliseconds, but others might be very, very long-lasting inference requests that might take 10 minutes or even more. This means that inside of Bedrock, we need to be very good at using the GPU resources, both efficiently and fairly, to make sure that as many customers as possible are able to access Bedrock and build AI apps. We also need to be able to isolate the jobs of each customer from each other to make sure that each of our requests are run independently. They cannot interfere with each other or connect with each other in any way. We also have to be able to support multiple tiers of service at different speed levels and at different price points. And to make this even more challenging, we have to do this both within and across different AWS regions. And last point, because models are introduced, they become popular, people use them for a while, then there's a new version after that. We need to make sure, as the models become older, that they don't continue to consume resources if no customers are using them. So these are the different challenges that we face when trying to make a good, strong implementation of Bedrock. The first implementation, we realized had all of those different challenges I just listed. And we, early last year, early 2025, we said, it's time, we need to rebuild that infrastructure to make sure we can move forward for our customers. So we launched a new effort directly on the orders of the Amazon CEO. He said, we've got to make this infrastructure better. And we called this Project Mantle. So it's actually, there's a very nice kind of a play on words between Bedrock and Mantle. If we look at the different layers of the Earth, we've got Bedrock close to the surface, and then a couple of layers further in, we have the Mantle, the very strong fundamental part of the Earth. So that's kind of where that interesting name came from. This was a very crucial project, and we launched it with an initial small team, a senior principal, which is a very senior engineering position inside of AWS, basically the equivalent of a vice president, and then a small team of principal engineers that are basically at the director level. Given the challenges and the requirements, the initial expectation was it would be about 1 year of development to get launched, and then a second year of development to get to the same level of features as the existing system. This seemed like a very long time to wait, and we knew our customers were wanting something better as quickly as possible. The team started out doing development the traditional, non-AI way, and realizing that these are some of the best engineers in the company, making them probably among the top engineers in the world. After just 1 month, they realized that they were not going to be able to build fast enough to meet their 1 year goal. And they had a couple different options. They first said, well, we can build a big development team, we can add 30 more people to that team, or why don't we experiment with some AI and see if we can do this job with a smaller team? Before they were ready to make a full commitment to AI, the team said, let's be careful here. Let's do an initial test. So they used a combination of QDeveloper and Kiro to take that first month's worth of work, rewrite it using those tools, and it took them just 3 days to get to where they had spent 1 month initially. That included writing both the code, the documentation, and unit tests. This told them that Gen AI could be used to build this level of infrastructure for Bedrock. Instead of having to add 30 more people to the team, they made it just a little bit bigger. They grew that team to just 11 people. And with all of these new tools, with all of this productivity, they were able to go from the starting point to launching in just 76 days. That picture I showed you from reInvent, where we were able to launch 18 new models so quickly, was enabled in part because of the work of this team. So what I'm going to do today, I'm going to review some of the lessons and the learnings that this team actually was able to capture as they were doing this really impressive piece of work. So the senior principal engineer in this picture, his name is Anthony Ligori. He's been at Amazon for almost 13 years. Very, very smart person, very accomplished, very productive and prolific developer. With the aid of AI, he reported some pretty incredible changes in his productivity. He said in just 5 months, he wrote what would have taken him 10 years to do without the use of AI. His personal productivity went from 2 commits per week up to 40. So he saw a 20 times increase in his ability to produce code. And overall, when taking other factors into account, he said he was between 10 and 20 times as productive. So this is really impressive. And I want to talk to you about some of the lessons that Anthony and his team learned along the way. To organize the project, They used a single source code repository, which we often call a monorepo, with all of the code, all the tests, and all the documentation. They used their tools to generate extensive documentation and then used that to feed that back into their models as they were developing. They took the time to architect and set up comprehensive local testing, including all of the services that they needed to call and all of the dependencies. So they could run local tests on their full stack, on their personal laptops, with no connections, no dependencies at all. They wrote by hand and also generated thousands of unit tests to prove the quality of the code. And they also asked the tools to generate code that would be friendly to future use and review by AI. So they asked the code effectively and said, make code that you will be able to easily understand later in the process. They settled into a very productive development cycle. And they could make important changes sometimes at a rate of 1 change per hour. And this is how they did it. They would prompt the model with the desired change. They would let the model figure out how to make that change. And so they actually would break down into 2 steps. Figure out what to do, and then actually do it. After the change is run, they would ask the model to run all of the unit tests and all of the end-to-end tests. And then, most importantly, the developer would look at the changes, review them very carefully, and make the decision if this was a change that should be committed. As they would do this, they were able to accumulate fresh code very quickly, which they were able to push to production the very, very next day. So as they were building Mantle, they were able to very, very quickly get code from idea to implemented, to reviewed, to checked in, to tested, to deployed in production. Here are some of the very specific takeaways that they offered as ways to get the most value from AI. Use small, specific tasks in your prompts. Use strongly typed languages so the model has as much information as possible to reason and to think about. We happen to use a lot of Rust in our implementations at Amazon, but I know a lot of others have had good success with strongly typed languages such as Go. The quality of your prompts is important and really is going to affect the outcome. I think what we have learned with this is that if you have a developer who is a good developer, the use of AI is going to make them into a great developer. But if you have a developer that's maybe not so good, makes a lot of mistakes, doesn't understand exactly what they're doing, the AI isn't actually going to help them to improve. So AI is going to really magnify the skills, magnify the power of a developer. It's also important to separate 2 actions when you're using your tools. You first ask the tool to search the code base, find particular elements of interest that you want to operate on. Maybe you want to change error handling logic, let's say. So you could write a prompt that says, look for all the error handling logic in all of my source code. And then you make a separate prompt that says, go and fix that. So go and fix the error handling to be totally consistent. We see that developers, as they start to go through this cycle regularly, as they get better at formulating high-quality prompts, we see that they gain confidence and they are able to build their productivity as they go. But with all of this, We see that AI is an extension of the strengths of a developer, and that the basic development skills that you've spent so long actually acquiring and practicing, so many of those skills still matter. That's so important, and I really want to emphasize that. The skills you've already built, the tools are going to help you to use those skills better. There were some interesting surprises in this process. It turns out that when you have experienced developers using these tools, they're going to produce code of about the same quality as if they had done it without the use of AI. So when we measure the bug rate of the code, and there's kind of an industry standard where you might say, how many bugs do you get per 1,000 lines of code, let's say. With good developers, you're seeing about the same rate with AI tools or without AI tools. So you're not making the code any better, but you're not making it any worse either. However, you're producing anywhere between 10 and 20 times as much code as you did before, which means you might be producing 10 to 20 times as many bugs as before. So those bugs are going to actually go through all of your processing and all your testing. You're going to catch some. They're going to slip through to production at the same rate, but with 10 to 20 times more code. You're going to see critical bugs get to production 10 to 20 times as often as before. This actually took all of us by surprise, but it turns out to be actually a pretty logical consequence. What does this mean? A couple different things I've been thinking. First, it means we need to increase the number of traditional tests that we're doing. We're going to ask our tools to be even more aggressive about writing unit tests and end-to-end tests. We're going to ask it to be very aggressive and very clever about creating those tests. So increasing the ratio of test code to production code, certainly important. But we also need to start thinking about new approaches to testing. For example, for the last 10 years at Amazon, we've been investing in what are called formal methods. So formal methods are effectively using mathematical techniques to prove the correctness of individual functions or entire programs. One aspect of this is called automated reasoning. And there's a lot of really interesting information about this you can read about online. But we can use testing to uncover certain sets and kinds of bugs. But we can also use automated reasoning to prove parts of our program correct. So as we can develop more code, we need to also increase our ability to find bugs in that code. Let's talk about different ways that as developers, we can get better value from the models that we use. We all know that as we load up more context into models, that we're trying to be helpful by supplying more information to the models, but the models at certain points have trouble keeping track of all this context. And when we have too many different tools in our configuration, we're really actually we're not helping the model to make smart choices. So load up as few tools as you can work with. Start new sessions frequently so that you clear that context. And I know that some of the tools are now giving you abilities to summarize sessions and save those and then restore the summarized session. So starting sessions frequently is helpful. Asking the model to load information on an as-needed basis. Rather than preloading everything, thinking that you're being helpful by putting this whole large collection of information, exercise your own judgment and load up that information at the point when the model is going to need it. It's also good to realize that the models are very good at mimicking or copying. If you have one piece of code that you've modernized, a very powerful prompt is to tell the model, follow the pattern in this updated module, and then use that same pattern in other locations. So I think what I come to realize here, the experience, the skill, and the judgment that we build as developers over a long period of time, my personal sense is that's going to matter more than before. It's almost easy to look at some of these tools and say, these tools do all of my job for me, and all the things that I've worked so hard to develop, that doesn't matter. I am very confident all the skills you've already built, they actually really do matter. Let's talk a bit about the way the world of building software is now changing. In every meeting that I have, I actually had 4 separate meetings at our headquarters yesterday. The question I get all the time, same question, every country I visit. We have senior developers with a lot of experience. We've got brand new developers, just hired them, fresh out of school. They've got a great education. They're very eager to do something. What is the path from junior developer to senior developer? And it turns out, from what we're starting to understand, is the difference between that junior developer and the senior developer, it's not all about technical skills. It's often indeed the case that the junior developer might be more fresh on various methodologies and skills than the more experienced developer. But what makes that senior developer more valuable is their experience, their intuition, and their ability to look at complex situations and make qualified, informed judgments on the right ways to move forward. So you need the intuition to know where do you look for a challenge or an opportunity or a problem, and then the judgment that only comes with that experience to say, this is the way we want to move forward. So within our industry, we need to make sure that we're training our newest developers to get that experience, to be able to put them into situations where they're exposed to complex systems, and we need to walk them through the process of developing those judgment skills. We also need to think of the language that we write prompts. It's not obvious. If we're a developer, we've learned a language, we've learned the syntax, we've learned the structure of the language. It's not obvious, at least not to me, how those skills translate into writing prompts for our favorite model. So we need to think of prompt writing as learning to express ourselves in a new language. We need to think about ways to shift left and to do our QA and to automate our build processes in every possible way to make sure that they are as efficient as possible. We need to make sure, for example, that every commit has to thoroughly build in all the desired configurations and has to pass all the tests. Now, this is another very interesting discovery. Even as developers, we can produce code 10 or 20 times faster than before. A lot of other parts of our system are now going to be stressed and strained to keep up with that. So we can think of that as effectively the downstream systems and processes. Everything that is after actually writing the code. This could be the ability of our code repository to accept commits and pull requests and merges at an accelerated rate. We're now asking that system to work 20 times faster than before. if we have a team devoted to doing code reviews, we're suddenly asking them to review 10 or 20 times more code. And if we have a CI/CD process, and we almost have to if we're going to reach the value of this, that CI/CD process is going to be activated far more frequently than ever before. So we need to make sure all these different aspects of our entire development process are able to run at the same speed as our AI-assisted developers. Otherwise, we find the slowest part of our system becomes the bottleneck. This seems somewhat obvious, but it was actually identified as a kind of a crucial law back in the days of the mainframes, way back in 1967. Anybody remember 1967? I do. Okay, I was around in 1967. Nobody else in 1967? Okay. All right. Anyway, 1967. Very good year. That's one of my grandsons, by the way, there. Okay, 1967, there was this guy, his name was Gene Amdahl. He was an architect of mainframes, and he realized that there's certain parts of a system architecture that can be sped up, perhaps by doing more work in parallel, but that ultimately the parts which you cannot speed up will turn into the things that slow down your progress. I will just read this for you. The overall performance improvement gained by optimizing a single part of a system is limited by the fraction of time that the improved part is actually used. Sounds a little bit formal. Let me give you a diagram to bring this to life. So we're a developer, we've got our agentic AI tool, and we've got a great idea, something we want to build. We spawn off, let's say, 5 agents in parallel. They're all working really hard to do work on different aspects of what we'd like to build. They each do their work. So we've got this, lots of agents all working independently. Ultimately, they're generating some fresh code for us to put into our system that we're building. So far, so good, because we've got all these agents able to work independently with no coordination. Suddenly, we've got 5 sets of code to review. We're now going to need more people to handle all this review work. And after those reviews, we're going to dump that all into our CI/CD, which is now going to be doing merging and building and testing and deployment 10 or 20 or even more times than ever before. So you can quickly see how the challenge here. We can build code faster than ever, but unless we make the other parts of the system after building code able to accept and process that code at that same speed, then making code faster will not be sufficient. As I think about this, I realize that some of the developments that we'll see in the coming years will probably help us to speed up the non-development aspects of these processes. If you're thinking about what the next amazing startup might be, perhaps you can think about how do we do reviews better? How do we make our CI/CD processes even more efficient? And with that thought, let me share with you a success story from an AWS customer, the BMW Group. They spent several years building a new CI/CD pipeline system. It can now handle 130,000 builds and deployments per day. This represents the work of over 3,000 developers and encompasses over 1,300 microservices. The goal of this multi-year project was to make sure that they could support a very rapid pace of development. And they did this with a serverless CI/CD architecture. I won't go into the details of the architecture, but what they were able to do is by going serverless, they're able to build across multiple AWS regions simultaneously, including regions in China. And they build for both Linux and Mac OS at the same time. So all of this work to make sure that the CI/CD pipeline was able to run and work as fast as the developers. Just last week, they published a very detailed blog post to give you a lot of information and architecture about this work. You can use that QR code if you'd like to learn a little bit more about it. It's also becoming kind of clear and obvious that teams and processes have to change. When we're building code at this new speed, we have to make important decisions at that same speed. So if we are building code 20 times faster, our decision-making processes have to be 20 times faster as well. There'll be more decisions to be made, and we need to make them quickly. We're learning that it's really important that all of the members of the team are in the same place and that they can talk to each other very quickly. The model of having a distributed team with people in different parts of the world working, that's being challenged by this new AI power because everybody needs to be close at hand and working together. There's a little bit of an extreme case of this I've been reading about lately, where developers, especially some startup developers, they've said, we need to fully optimize our lives around this level of productivity. We're going to get a big place. We're all going to actually live there and work there together. We're going to call it a hacker house. Now, I would like to have a little bit of separation between my work life and my personal life, so not fully recommending that, but this is kind of the extreme case of what developers are doing to be productive. But in any case, it's really clear that we're scaling up the level of interpersonal communication that's required, and that the traditional agile model of having daily stand-ups and perhaps weekly meetings, it's not those meetings are too far apart and are not they're not helpful. So we're going to see development processes have to change. Now, we have this kind of famous model at Amazon that for 3 decades we've called the two-pizza team model. And the two-pizza team model said, keep your development team small. In fact, keep it small enough that you can feed them with 2 pizzas. We never really said how hungry these team people are. We never said how big are the pizzas. But the idea was, keep the teams kind of small. With the power of AI, I'm now starting to think that the teams have to be even smaller. 1 pizza team per product or feature. This is going to mean that each developer on that team is probably going to have a more broad set of skills, and each developer is going to have more control and a broader scope of work as they are actually building. So more skills, more scope for you as developers. As I start to think about development models, so when I started programming, this was back in 1970s. You couldn't sit down at the computer and experiment. It was kind of hard to actually get time to be on the computer. So you spent a lot of time simply taking the the reference manuals, reading page by page. Make sure you fully understood the language syntax, the data types, and the operators, and you basically committed everything to memory. So to me, it was kind of like a digital model, where you'd say, as long as I have all the facts related to the language, I'm now a capable programmer. The new world is very different. Every one of these different models that we have has different capabilities and strengths and weaknesses. There is never a reference list that says, here is the long list of things that this model can do. The only way you can find that out is by sitting down yourself and trying it out. So we need to go hands-on, we need to explore. Now, it's also the case that the style or our philosophy around applications is going to change. In the world of the past, we would invest a lot of time, a lot of money, a lot of people into designing, building, testing, deploying an application. After we had made such a big investment in that application, we think of it as very, very precious. And we're going to keep the code around for a long time. We're going to maintain that application year after year after year, because we had made that very big investment just to get it started. The new world is quickly feeling very different. It's not that hard to build applications anymore. So we're going to think of the applications as more short-lived. Instead of maintaining them for year after year after year, we'll rebuild them every so often with a fresh understanding of the customers and the problems. Maybe we don't save the code for a long time, but our problem understanding, our prompts, our specifications, we'll keep that around. That will be the more interesting artifact of development. So we can think that there's now disposable code for our applications. Think of that as effectively short-lived code. And then underneath that, our more durable code, our microservices, our tools, maybe our models. Very interesting combination that we'll see here. The disposable code that we don't really care too much about for the long term, and the durable code that we do care about for the long term. I think that while the life of our applications will get shorter, the life and the value of our data collected, analyzed, used by those applications, that's going to get more valuable, because we can more easily build applications to reference data. Okay, the data itself will become more and more useful and more valuable. And for us as developers, we're going to see that in the past, we often had very specialized skills that because we were part of a very large team. But in our new world, we're going to have to be more general purpose. We have to be generalists. We're going to have to be able to adapt to new situations and environments. We're going to have be resourceful people that can take on a lot of different kinds of challenges. And to because we're part of a smaller team, and maybe we are the entire team all by ourselves, we're going to have to become more self-sufficient. Let's wrap up and talk about some ways that we can start building these next generation skills. These are just the 5 kind of things I'm thinking are the categories that we should focus on. Because we're going to be increasingly close to our customers and our users, we need to be really good at understanding those customers. We need to be able to understand their business and their use cases. We need to look at the very important fine details of the challenges faced by those customers. We also need to totally think about ways to improve our communication skills. We need to be expressive in our communication, whereas when we write traditional source code, we're always told, keep it short, to the point, write as little code as possible. In the prompt-based world, more words are going to give you a better result. To become great communicators, we need to write a lot of words, read a lot of words. We should increase our cooperative skills, learning how we can be team players, how we can feel tightly connected within our team, and probably working in the same physical location with our team. I listed concentration as a skill here because with so much going on, with so many new tools and models and processes happening every day, at least for me, it's really important that I stay focused, keep that mental clarity that says, yes, everything is changing, but I will find some focus and some stability as I do so. And I also recommend that we find a way to learn something new every day that somehow as part of your discipline of how you set up your schedules for the day, you make sure that you have some time that is just, what do I learn? What is my new fact or new model or new tool? Even if you're saying 15 minutes per day, that's the world is changing so fast that 15 minutes per day is essential to keep you moving forward. Okay, now I have one more recommendation that is maybe already just about obsolete. For last year, I told developers, I said, you need to make sure that after your AI writes code for you, that you can actually read and understand that code. Seemed like a good recommendation for the time. When I talk to developers, including those in my own family, my two sons both use AI tools for part of their jobs, and I say, you do look at that code after you write it. And they're like, no, Dad, that's kind of the old way. We just generate the code and it always does what we want. So I'm not sure that's actually a thing anymore. I do think that our communication skills, our ability to speak and to write, are more important now than ever before. Our ways that we communicate with our customers or our audience, the ways we talk effectively to our AI dev tools, the ways that we talk with our teams and our peers. But also, something I'm very excited and happy about is, for most of my time, it was the case that you effectively had to learn English in order to be a developer. Most of the documentation, the programming language, the error messages, the support, the communities, we're all kind of English-centric. What I'm finding with all of these amazing models we have, the models recognize and can work with you in so many different languages. So this to me is great, because this means that we're opening up development to more people with more backgrounds. And historically, as we do this has meant that more people have the ability to build and to get the benefit from technology. All right, so to me, this is kind of an interesting contrast. I was trained to write code, like on code we see on the left. Very carefully formatted and structured, efficient, and to the point. Today, we write like that on the right. We write these prompts with structure and rules. We probably use Markdown as our syntax, and we're giving guidance and suggestions and rules and sequences to our AI tools. I'm thinking that those of us that are really good at writing like the left, a lot of us are going to be able to do the same on the right. Some of us were thinking, I have some learning to do in order to work like that. And that's okay. That's what our field is all about, is always learning and adapting to whatever is new. But again, another way to just prove the point, communication is more important than ever. I like this quote at the end of this paper. Knowledge of specific language, syntax, and frameworks, and code is no longer a bottleneck. It's more about the developers who can talk well, they can define problem statements, they have an advantage over someone who cannot. And with that, I'm just about at the end of my talk. As always, I've enjoyed preparing this, presenting to you. I do hope that these ideas were helpful to you. I'm going to be around for a while until early afternoon, and would love to catch up and say hello if you have the opportunity as well. So thank you so much for watching, and as always, my trips to Japan to speak to you are always the best. Thank you so much. Thank you.